Do you want to control any device from your mobile? Do you want to design Wi-Fi switch? Then stay tuned till the end. In this video, we are going to design a Wi-Fi switch using ESP8266 or also called as ESP01 Wi-Fi module. Hi, my name is Amit. Welcome to my channel. When I say control any device through your mobile, which means we are going to use 8266 as a server, as an access point in which it will be holding a web page, and whenever you ping to that server from your mobile, you are going to see a web page. There will give the access for a user to click the button so that you will be able to control a device. So in here we are interested in designing a page as well. Page would be designed in an HTML, and if you have downloaded the code, the link given in the description below, you would see that there is this folder, and this folder contains two files. That is, one is HTML file and the another one is the Arduino file. So first of all, let's create our web page so that we'll be able to handle it through our mobile. So to do that, we if you could open this in the notepad, you'll see that this contains this code, and here what I'm going to do is I'm just going to copy this on because here with this only code I'm not able to see how my page is going to look like. So what we'll do is we'll copy this code, we'll jump onto the online editor, and the w3school.com, it has got a great GUI and great user interface where it gives us the facility to simulate the code as well. So here I'm going to use the CSS one, and let's click on here, that is try for yourself. And when you click that, which means the code written over here is going to execute and show the output simultaneously on the other side, that is on this side. So we are interested in understanding how our code is functioning, how our GUI is going to look like. So I'm going to delete this code, and we already have copied that, and let's paste this up here. Now let me explain what all things we have here. That is, this is in HTML syntax. So we are interested in understanding this meta, which means this is a special syntax given by the HTML or CSS language, which shows that it is going to make our code independent of the browser size. I mean, like if you are accessing this web page from your mobile or from a laptop or a desktop, the buttons and text is going to get proportionately changed depending on the screen. So this is what we need to include here, that with the scaling factor 1, so that it gets adjusted according to the size of a screen. So here we create the style of our page, that is the body font is going to be 150%. Now we can make it to 100, and let's figure it out how our GUI is going to look like. So I'm going to make the font size percentage to be 100, and here is the main padding, that our main since we are going to have two objects on the page, that is the title and the button. So that main object shall be in the middle, so that here we have mentioned that. Now next is our header 2, which means the title of the page. It has to be centrally aligned, and we have button attributes here. We need to set on those. You can try changing those parameters. So here it says the padding, so that the button would distribute very neatly about the text were printed within that button. Okay, so you can change this out and check for yourself. So the background color, yeah, this looks this is the color code, and to find out the color code, here you can simply go on to Google and check the color code. Let's see how can you check that as well. Okay, color code picker. Right, so you could see that this is a color code picker. So if you just move this bar over here and there, you could see that there is an hex or a different format values as well. So I've got this value from this. Let me see. Yeah, so here is the code, and I've just copied that code and put it over here. Okay, so with that, I'm going to see my button to be of certain color. So then font size of the button, then what should be the color of the text matter printed in that. So let's since the button is a little dark, I'm making the text as white. Okay, and this is the border radius. It's good to see the rounded button, and it is centrally aligned. So this is how my page style is going to be. And here we are going to create a container with this syntax, and within that container I'm going to have two objects, that is the header, the name given to the page, that is device control, and next we have the form. Actually this is a button, and this button is going to have certain actions. So we are going to talk about this particular line in the Arduino code as well. So let's here understand that the action to be taken is device off, and the value printed on that button is going to be turn off the device, and let's see how can we turn on that as well. But this is how this code is going to look like, and if I run this, it will show me how my device, how my GUI is going to look like. Okay, it simply shows that there is a text and a button with the text written in here. Okay, we are good to see, good to go as I am satisfied with the design. If you want anything to be added, to be deleted, you can, you are free to do that. You can test this out for yourself, right? So let's now jump on to the Arduino part of part. But before going to the Arduino section, here we are interested in converting this HTML syntax into a string, because within the Arduino it expects this HTML code to be in a string format, and I was just searching this out, that how can I easily convert by the tool itself, because otherwise you can do it by manually for sure. Everything has to be in the same line. That's what it is expecting, that there should not be any inter characters. But again, this is a headache. So I was searching this out and I got this solution. This is one guy who have created this application. So here we just need to copy this code and paste it over here, and it is going to convert it into string. So the interesting part starts here, that I am going to divide this code into 3 sections. First section would be up until this, that I'm going to copy this part, then I'm going to copy this, and then this. So I've converted this code into 3 strings. Okay, 3 strings. So first let's just copy this one. Okay, copy this, and you just need to place it over here. Okay, and then say just convert. Now it is going to convert, and the entire syntax is also correct, that we have the semicolon at the end, we have string data type, and we have name for that variable. So you just need to copy this and paste this into your Arduino code. Okay, in the similar way I'm going to do copy this one, and let's just paste it over here and convert. Boom. So this is how I'm going to get 3 strings, and the last string is going to be just this one. Just copy it and convert. That's it. So this is how I'm going to get 3 strings out of my HTML code, and we are now going to use that into our Arduino code. So let's jump onto our Arduino and let's understand how to use this. So here if you could just see the folder, here we have the Arduino code as well. So that's what I have opened over here, and here it says here, let me explain the flow of the code so that we'll be able to use it, right? So first of all, libraries need to be included since ESP8266. And first of all, even though few of you know that we are going to put this code into our 8266 modules, Wi-Fi module, and this is not going to sit onto the Arduino, right? This code is going to go onto the ESP8266 Wi-Fi module, okay? And later on, there is no role of an Arduino Uno board in the functioning, okay? So that's what I mean here. So first of all, let's include the libraries, then give a name to your access point. Now here we have created a name as device control. Password needs to be given, and password shall always be 8 to 16 bytes, okay, 8 to 16 characters, because if you put less than 8, then this naming convention is not going to be accepted. And if you just don't need a password, you can keep it blank, that's okay. But password, when you set a password, it should be of 8 characters at least. Then I'm going to start the server variable, and server is going to be created at port number 80. You can change this to changes to any number, but this is what the standard is. Everybody uses this port, so I've kept this as it is. Now here the string that we have converted, I've given a separate name for those variables, that is HTML main, HTML button. This is going to be button, and if you could see here it is blank, but for sure we are going to have some data over there in the below section, and end of course, right? So here I've also created one of the string, which is actually a written code whenever client is connecting, okay? So because we need to notify our client whether he is successfully connected to the server or not. So this is what is the syntax to mention whether the connection was successful or not, right? So this is how is going to this header is going to play this role, right? So let's create another variable called string, and here we have device pin as 2. If you know, let's jump onto the data sheet over here. Now this VCC ground, we know RxTX actually is 1 and 3, GPIO 1 and GPIO 3, and we have 2 extra pins available over here, GPIO 0 and GPIO 1, okay? GPIO 2. So here I'm interested in using GPIO 2 because GPIO 0 is going to be used to program while programming the 8266. So when I'm going to talk about it later when we do the programming part, but here I'm interested in using GPIO pin number 2. So here in the code, if you could see, I mentioned it to be pin number 2. And first of all, let's make this pin mode as output, and our relay is in active low, so I've initially made it low. Then we are going to create a soft access point with the credentials that we have given, that we have here mentioned. So with these credentials, it is going to create a server. Okay, it is going to create a server, and we already know the IP address of it, or otherwise you can print the IP address as well. So we are not interested in here printing that IP address because I'm sure that it is going to create that particular IP address. Okay, yeah. So server begin, we have set up the code perfect. So this part is going to function for once. And here we have a loop, and within loop, now we are going to create the client variable, and we are going to see whether the client is available or not. So here is the client variable created. Okay, Wi-Fi. This is the data type for the object, and here if the client is connected, it is going to return is true. Okay, this server dot available, right? This is going to return as true, and if it is true, which means this becomes false and it comes over at this part. But if it returns false, which means the condition becomes true and it returns. And when it returns, it actually deletes the client object as well. Okay, so we need to create it the object again and use it multiple times. So here whenever the client is connected, whenever you connect with your mobile to particular your server, now with this server we are expecting a string out of it, because whenever anybody clicks on the button, that button is going to send the string to our Wi-Fi module, and this Wi-Fi module is going to accept that string until this /r. That means this is a built-in operation, because at the end of the string you are going to get this carrier return part. So with this request, we are going to get the index, or what that index does means. And with the index part, if you see that whenever in URL gets created, we are going to see that the URL when we can actually connect. So with the request, within the index we get the device on and device off. That's how we have programmed it. So we are going to get the same, right? And whenever if it is a device on, and if it is true, if it is greater than 0, we are going to make our pin high, right? And to the pin we have connected the relay part, and at the relay it is going to turn on our device. Perfect. So with device off, it is going to make this device off. Now here we are interested in reading what is the status of the pin. Now if it goes high, here this condition becomes true, and if it is true, it will get into this section. Now here we are going to give the string that we are interested in. With this, actually, if you could see that we have only one button available here, right? We have only one button available here, and this same button is going to show us turn on the device, right? So that's what we are going to we have did the modification over here. Now with this string, now it says that device off and turn on the device. Okay, this is the action that we want to happen, and this is going to be displayed on the button, right? Next, if the pin is low, now the action that we want to happen is device on. That is the device on, and here on display it is going to show us turn off the device. Okay, so this is what is going to happen. And now how to show that onto the mobile's page actually. So with client.flush is going to flush the previous screen, and here the header is going to give the feedback to the client that it is connected to the server successfully. So with header, clients get to know that the client application gets to know the server is alive, and with this we are actually going to show the page. So with this, all the style is going to be there, and this is where the button is going to be displayed, and then the end of the page. Okay, so this particular button is going to take two options, that is to turn on the device and turn off the device, and we'll give the 10 milliseconds delay, and with this delay we are going to do the same again and again. So unless and until there comes a request from the user, it is going to stay in this particular part. Okay, so once the button is clicked, okay, it will give whether the index for this request becomes device on or device off, as we have mentioned over here that these are the actions to be taken. Okay, and the next time whenever user clicks the second time, it is going to definitely give the other option, that is device off, and we turn off the device, right? So we are good with the explanation of this code. You have this code available. There is a link in the description box. You can download this code and use this code as you want, right? So let's jump on to the hardware part. Let's connect with our hardware. So here we have hardware that this is the relay board. This is my 8266 board. that is ESP01. This is Arduino. We are actually going to use this Arduino to just to program this, and with this we are going to actually connect our relay board, and it is going to function. This is just the bulb holder to just test this out, whether this application works or not. Yeah. So let's jump on to the wiring part. So let's first understand how our wiring part is going to take place with this diagram. So in here we actually have two sections, that is relay. So this is going to be my relay, and a relay, if you might know, that it has 3 pins. That is, this is common, this is NO, normally open, and this is normally close. So normally close, and here is the coil for our relay. And if you see that this coil is of 5 volt, which means we are going to give here the 5 volt plus 5 volt. Now to turn on this relay, we need to pass on the current, and to pass on that current, we are going to use the transistor driver. So here I have this transistor, and this transistor is actually going to be placed within, let's imagine that this is the driver, and this transistor. Okay, so whenever this transistor turns on, the current flow is going to be there within this relay, and our relay is going to turn. This common point is going to switch to the NO part, right? And here actually on the relay board we have LEDs. We have optocoupler over here, optocoupler, which means within this IC, optocoupler IC, we actually have this complete assembly, right? So we have this LED and the transistor available in here. So at the output, within the circuitry part, we are going to do this, and this is going to go to the GPIO pin 2, right, of ESP. So here I write ESP01 GPIO2. So it is going to go to GPIO2. So whenever GPIO pin 2 go high, this turns on, which in turn this transistor turns on, and our relay turns on. And how are now we going to connect our bulb? Let's understand that as well. So here our bulb is going to get connected, and bulb is a AC part. So here we are going to use this phase part and neutral. So we'll take this neutral and is going to get connected to the NO part, and this common part is going to connect to our bulb. Okay, now imagine that this relay is in off state, and so which means this NC part is connected to NO, and there is no connections, which means the circuit doesn't get complete, and circuit doesn't get complete, and the connection is the bulb is going to be off. And whenever this turns on, which in turn this turns on, and this common point is now get connected to NO part, and so that our circuit completes and this bulb is going to glow, right? So this is how we are going to get we are going to wire this on our hardware. So let's jump on to the hardware part. So the wiring part for this ESP8266 is being done with the Arduino, and we are going to do the code download on this ESP8266. Okay, so to download this code, you must follow a particular sequence, that this RX pin is connected to the RX pin on the Arduino board, because the data is directly going to go towards the 8266. Okay, and so you should not cross the pins. That means that RX should go to the RX on the Arduino Uno board, TX should go to the TX on the Arduino Uno board, right? So this pin number 7 and pin number 5 is shorted with the link of the red color, and VCC ground is being given. This GPIO 0 is going to act whether this board is in the program mode or in the run mode. So whenever this GPIO 0 pin is 0, that is low, it gets into the program mode, and whenever it turns it's not connected to the ground, that means it is in the functioning mode. So while programming, I've if you could see, I've connected that GPIO 0 pin to the ground pin. Okay, so this our orange wire is our GPIO 0, which is connected to the ground, right? And we have resetted once. So this is the sequence that you have to follow, that is connect this to the ground, VCC ground is given, RX TX is at the respective pins, and with this set you just need to reset once. Reset is active low, so you can touch just that wire to your ground and the circuit would be resetted. So I know my Arduino is connected to port number 7. So this is the port number 7. If you could see, the one interesting point that you should note is that if you are interested in using a built-in LED, so for ESP01, that is ESP8266 Wi-Fi module, internal LED, built-in LED is at pin number 1 if you happen to use that. And here it is quite an interesting thing, that is debug port serial has to be enabled, so that a few of the debugging messages comes on the screen, so that you get to know what is actually happening with it, right? Yeah, so with this we are good to go, and let's hit on the upload button and download our code. So here comes the error, and error says that invalid unsupported command. Right, so this actually means that our serial connection is not done properly. That's the only reason that we get this error, or the sequence of our programming is not understood by the software. I mean, like we should reset our hardware before programming, right? So I'm going to do the reset part over here. I'm going to reset my ESP8266 once, and just touch to the ground, and it's okay, right? And let's try doing it once again. Yeah, so here you could see that it has started programming, which means it is writing different sections on the ESP board, and this will port our application within the board, and we'll be able to use that. So this has uploaded our code onto the ESP8266 board, and we'll do the further wiring of the relay, and we'll see how can we access it with the mobile. Perfect. As we have already connected all of our devices all together, like relay is connected to AC bulb, Wi-Fi module is connected with relay and Arduino board. Arduino board is actually giving a power to our Wi-Fi module, that is 3.3 volt. That's it. Otherwise, you could see all the pins are open here. Now as our access point is ready, we can now start using our application. So you just need to go on to Wi-Fi setting, and it will show you the device ID, okay, SSID. So here I see my device ID, that is device control. I'm going to click that, and our password, remember that we have set in the code, that is 0 1 2 3 4 5 6 7 8 9. We are good to go. And yeah, I'm connected to the device. Now you simply need to go onto your browser, and in browser you shall type this IP address, that is 192.168.2.1, and when you hit this device, it will show us the page that we have created within the HTML. So here it shows that turn on the device. Now I'm going to click that, and my device is going to turn on, right, perfectly. So here again, if I turn it off, my device is going to turn off. So what actually is happening is, whenever I send a command, the server actually runs in background, and it is turning that GPIO pin number 2 to high or low, right, like this. Awesome. As that we have seen the working of our entire project. If you are interested in understanding how the radar application works, here is the link for you. And if you are interested in using Python GUI with PIC microcontroller, here is the video for you. If you like this video, give it a thumbs up and subscribe to my channel so that you get notified whenever I upload a new video, and don't forget to hit that bell icon. That is in this video. See you in the next video. Bye bye.